This is chapter number 5, that is elasticity and its application. Let's start this with a scenario. This will illustrate important concepts such as impact of price changes on sales and revenue. So let's say in this scenario, you design websites for a local business. You charge $200 per website and currently sell 12 websites per month. Your costs are rising, including the opportunity cost of your time. So you are thinking of raising the price to $250. The law of demand says that you won't sell as many websites if you raise your price. But how many fewer websites you sell? We know that price goes up, people want less, but how much less? How much will your revenue fall, or might it increase? But before we go there, let's understand what is elasticity. Basically, elasticity measures how much one variable responds to change in another variable. One type of elasticity measures how much demand for your websites will fall if you raise your price. Definition of elasticity is: it's a numerical measure of the responsiveness of quantity demanded or quantity supplied to one of its determinants. So how does the quantity demanded and how does the quantity supplied change if price changes? This is all about the definition of elasticity. Now here comes the price elasticity of demand. There is the formula for the price elasticity of demand, that is percentage change in quantity demanded divided by percentage change in price. Price elasticity of demand measures how much quantity demanded responds to a change in price. How much quantity demanded changes up or down when prices change. Loosely speaking, it measures the price sensitivity of buyer's demand. Here comes another slide for price elasticity of demand. Let's take an example here. Price elasticity of demand equals when price rises by 10%. Here if you see that there is a change in price from P1 to P2, that is 10%. You can say that price rises by 10%. Here it is. That's a percentage change in price and quantity falls by 15%. Initially it was there at this point, that is quantity demanded denoted by Q1, then decreases by 15% and comes on point, that is Q2. That's the percentage change in quantity demanded. Simply it is, you can say 15% divided by 10%, that is percentage change in quantity demanded, that is 15%, divided by percentage change in price, that is 10%. So we just put the values in this formula, that is 15% divided by 10%, and the price elasticity is equals to 1.5. So this is how we can calculate the price elasticity of demand. Now, Along a D curve, that is demand curve, price and quantity moves in opposite directions, which would make price elasticity negative. Which makes sense because demand curve is negatively sloped, as you can see here. If price increases, quantity decreases. So price and quantity move in opposite direction. And the demand curve is negatively sloped. We will drop the minus sign and report all price elasticities as positive numbers. It's worth noting price and quantity moves in opposite direction, which means that percentage change in quantity and percentage change in price will have opposite signs that show that a negative price elasticity when you think about the ratio. Reporting price elasticities as positive number, it's really better to say absolute numbers, or you can say non-negative numbers. So whenever we are going to find out the price elasticity, we will drop the minus sign and report all the price elasticities as a positive number. Now comes calculating percentage changes. Standard method of computing the percentage change is end value minus start value divided by start value multiplied by 100%. Now here is the graphical representation. Going from point A to B on graph, the percentage change in price equals to you can say $250. Initially price is $200, and then at this point this is $250. That is the end value, and $200 is the start value. So $250 minus $200 divided by $200 is equals to multiply by 100% is equals to 25%. So this is the percentage change in price. We just put all these values in this formula. Here the end value is 250 minus start value, that is 200, divided by start value, that is 200, multiply by 100%, which is equals to 25%. So this is the formula for calculating the percentage change. That is end value minus start value divided by start value multiplied by 100%. The problem here is the standard method gives different answers depending on where you start. From A to B, price rises by 25%, as we have seen this in the previous slide. Here, if we move from point A to B, then the price change we get is 25%. Quantity falls by 33%. By the same formula, if we put the values of the quantity demanded in this formula, we get the percentage change in quantity equals to 33%. And then we can find the elasticity, that is 33 divided by 25 is equals to 1.33, and this is from this formula, that is percentage change in quantity demanded divided by percentage change in price. This is the formula of price elasticity of demand. and with this formula we can calculate the percentage change uh, in either the price or in quantity demanded. And here we have the percentage change in price, that is 25%, percentage change in quantity demanded, that is 33%. Then we can easily calculate elasticity, that is 33 divided by 25 is equals to 1.33. However, if you move from point B to A, price falls by 20%. Now, if we move from point B to point A, then obviously it shows that there is a fall in price from $250 to $200, and the percentage change in price is equals to 20%, again using the formula of percentage change. And quantity demanded rises by 50%. That means from quantity demanded 8 to 12 units, you can say that the percentage change in quantity demanded is equals to 50%. Then the elasticity would be 50 divided by 20 is equals to 2.50. This can be confusing if you don't pay attention to where start was and whether you are moving from point A to B or from point B to A. To avoid this, we use what is called the midpoint method. When calculating percentage changes, we simply take the end value minus start value. However, instead of dividing by simply the start value, we take the midpoint. The midpoint is the number halfway between the start and end values, the average of those values essentially. If you remember in our previous example where the start value was 200 here and the end value was 250, then the midpoint will be 225. So we calculate the midpoint here. So the midpoint comes by the formula, that is, if you can see here, $200 plus 250 divided by 2, which is equals to 225, and this is the midpoint. So from the previous example where the start value was 200 and end value was 250, the midpoint will be 225. It doesn't matter which value you use as start and which is the end, you get the same answer. Either way, so this deals with that problem when you use a standard calculating percentage change issue of where you start, whether you go from B to A or A to B. This addresses that issue. Likewise, if we put the end value in start, that is, if we add 250 plus 200, divided by 2. Again the answer is equals to 225. So by taking the midpoint, we can solve this problem of calculating the percentage change issues of where you start, whether you go from B to A or A to B. This addresses that issue. Now calculating percentage changes. Using the midpoint method, the percentage change of price equals 250 minus the start value, that is 200, and then divide by the midpoint, that is 225, multiply by 100%. Then we get 22.2%. So that is the percentage change in price. This is just for percentage change. This is not the elasticity calculation yet. The percentage change in quantity is equals to the end value. We had a quantity demanded of 12 and a start value of 8. So 12 minus 8 over the midpoint, which is 10 here. Then convert that into percentage terms and you have a value that is 40% change. So you have 22.2% and 40% change. The price elasticity of demand is equals to, you can say that it's equal to change in quantity demanded, percentage change in quantity demanded over percentage change in price, that is 40 divided by 22.2, which is equals to 1.8. That is the price elasticity of demand. Now comes active learning. Calculate an elasticity. Here, use the following information to calculate price elasticity of demand for hotel rooms. If price is equals to $70, quantity demanded is 5,000, and if price is equals to $90, quantity demanded is equals to 3,000. So price went up and quantity went down. You can see there is a rise in price and there is a fall in quantity demanded. Now coming to the solution of this active learning question, we are going to apply our midpoint method here to calculate the percentage change in quantity demanded, that is 5,000 minus 3,000 divided by the midpoint, which is 4,000. And how we calculate the midpoint? Again, adding these quantity demanded, that is 5,000 plus 3,000 divided by 2, that is equals to 4,000. Here it is, the midpoint. And the percentage change in quantity demanded is equals to 50%. You can note that the ending quantity demanded is 5,000 and the starting quantity demanded is 3,000. So obviously we must taking about the price decrease of $90 to $70. So the percentage change in price is equals to $90 minus $70 divided by 80, that is the midpoint. Again we have calculated midpoint like $70 plus $90 divided by 2 is equals to 80. So here is the midpoint. And you can say that 90 minus 70 divided by 80 is equals to 25%. That is the percent change in price. The price elasticity of demand is equals to 50%. That is the percentage change in quantity demanded divided by 25%. That is the percentage change in price, which is equals to 2.0. That is price elasticity of demand. So this is how we calculate the price elasticity of demand using midpoint method.